Okay, so today we are going to learn about decision trees and random forests. So first we will understand what are decision trees. Okay, so decision trees are actually both classification and regression model. So it can be used. Decision trees can be used for both classification, like just now how we have seen for the logistic regression. It can be used for classification as well as regression. Okay, so in linear regression we saw how we can predict the continuous variables, right? And in logistic regression we saw how we can predict the categorical variables, right? But decision trees can be used to build both kind of models. Like it can be used for classification as well as for regression. Okay, so decision tree, in the name itself we have the tree. Okay, so it's like it builds up a tree kind of a structure in order to classify or to predict um, certain output. Okay, so finally we get a tree kind of a structure uh, after applying this model, right? So how it does that, it actually breaks your data set into smaller and smaller subsets. Okay, until you get your final classification or the final classes that you want. Okay, and so here we have one example. Okay, so let's say you have hosted a birthday party at your place, and after the party you wanted to estimate that how many people in your party were non-vegetarian. Okay, so how many people were non-vegetarian and how many of them were vegetarian? This is the problem statement. So you want to know how many people were vegetarian and how many people were non-vegetarian who have attended your party, right? And now you will see that this is a problem of classification, where you have to classify your guests as whether they are non-vegetarian or non-vegetarian. Okay, so to do that you will ask certain questions. Okay, you will ask certain questions, and based on those questions you will keep on dividing your guest population, or the guest, or all of the guests that had visited you. You will keep on dividing your guest population based on these questions. Okay, so let us see how. So the first question that you may ask is, did the guest eat chicken? Okay, did that guest eat chicken? If the answer is yes, then you could classify him as, okay, the person is non-vegetarian. Okay, but the answer to this question, if it is no, then you will ask another question, that did the guest eat mutton? Okay, so again, here we have two options, yes or no. So if that person has eaten mutton, then you will classify him as non-vegetarian. And again, if he has not eaten mutton, then you will ask another question, that did the guest eat seafood? Okay, so based on these question, based on this last question, whether he would have eaten the seafood, then you will classify him as non-vegetarian. And if he has not eaten this, then he is vegetarian. So a um, this is how a tree develops. Okay, it keeps on dividing your data set into smaller and smaller parts until you come to the final stage, which is the classes, in which you want to divide in which you want to classify your data points, right? So now over here, these questions, actually you won't ask these questions or something in your model. No, these questions are actually these questions actually signify the features. Okay, so whatever features or the columns that we have in our data set, your data set will be split based on those features or those columns, right? So So these, let's say these three are the features or the columns that are present in my data set. Okay. So whether that guest has eaten chicken. If he has eaten chicken, then let's say in my that data column, I had marked yes. Okay. Or something like that. Or it could have been some numeric, like if he has eaten that, then we would have put 1. And if he has not eaten, then we would have put 0. Okay, so in this way you have your columns or your features in your data set, and based on those features, you will split your data set into smaller and smaller parts. Actually, you don't do it. Your model will figure it out how this splitting has to take place. Okay, you just have to provide some measures and some parameters to your model, and your model will do that for you, right? So let us understand some parts of this decision tree. So the first node over here, or the first feature based on which your data is split for the first time, okay, in the beginning, this is known as the root node. Okay, so the topmost node is known as root node. So here is the first question, okay, that whether that person has eaten chicken. So this is being the first split in our decision tree. It We will split our data set into two parts. Okay, we are splitting, right? We are splitting our data set into two parts. So these are the branches, right? So these two are the branches, because we are splitting our data set. These branches could be many, right? Now for this particular question or this particular feature, we just had two outcomes, whether yes or no. But it could be that you may have more than two branches, right? Then these are the internal nodes. Okay, so both these, the whether the guest has eaten mutton or whether he or she has eaten seafood, these two are the internal nodes. Okay, since they appear inside or internally in the decision tree. So these are the internal nodes, and the final nodes, or the nodes at the last stage, okay, based on which we are actually able to classify are our leaf nodes. Okay, so leaf nodes appear at the end, and these are nothing but the classes that we have, or the classes on which we have to divide our data set. So these are the leaf nodes which appear at the end of our decision tree, right? So this is the structure. Now let us learn about the advantages of decision trees. So as we have already discussed, that decision trees can be used to predict both continuous and discrete values. Okay, that is, they will work well on both regression and classification tasks. But primarily, for most of the times, decision trees are used as classifiers for classification purposes, but you could use them as well for regression, right? Then we have then the next advantage is they require relatively less effort for training the algorithm. Then they can be used to classify non-linearly separable data. So if you remember, in the linear regression, we had this disadvantage that if your data is not linearly separable, you cannot use linear regression. Okay, but in decision trees, this is not the requirement. Even if your data is not linearly separable, that is, when you plot your data, one line, by one line you could separate your data. Okay, even if that is not possible, even then you can use decision trees on such kind of data, like, right? So for non-linear data also you can use decision trees, and these are very fast and efficient. So when you have huge data, right, when you have very huge data, you should you might think of applying decision trees, because they are very efficient and they are very fast. Okay, so these are some of the advantages of decision trees. Now let us understand how does a decision tree will decide which feature it should use in order to split. Okay, in order to split your in your data set. So let's say how did my decision tree decided that whether the guest has eaten the chicken or not should be my root node. That is my first split. Where should my first split happen? So how does our decision tree decides this? Okay, so let us learn how does it decides. Okay, so basically there are uh, two concepts. So first one is the Gini, and second one we are going to also learn about that. So second one is the entropy or the information gain. So these are two concepts based on which this splitting is decided, like which feature should the decision tree use in order to make the split. Okay, so let us understand a little bit of mathematics which is involved. uh, okay, so let's say so this I have found this in one of the blogs, and it is very like very easy to understand uh, the concept. So I have just used that over here. So let us first see over here one example. Okay, so in this example we have to we have two features with us in this data set, that is the gender and class. Okay, so whether that person or that student is in which standard, 10th or ninth, and whether that person or a student, whether that person is female or male. So we have these two features with us. Okay, and we have to identify that we have to predict if that student plays cricket or he doesn't. Okay, so we have to do that. We have to predict whether that student is uh, whether he plays cricket or he doesn't play cricket. So this is our objective, and we have to derive our decision tree, for which we have to decide based on which feature should we split our data. Okay, so here we will see first we will learn about the uh, uh, Gini concept over here. Okay, so how is this Gini parameter calculated? So this is the formula. This is nothing but the probability square of that particular event happening plus the other bit or the complementary of that probability, that is 1 minus p. This is nothing but q. Okay, so the probability of other event happening, okay, it's square. This is the simple formula how we can calculate the Gini, right? So let us understand this by seeing this example. So let us say that we split our data based on gender. Okay, so total we in our data set we have 30 students. Okay, and out of these 30 students we know that 15 students play cricket. Okay, so 15 students play cricket out of 30. Now let's say we are splitting our this data based on gender. Okay, so when you split your data based on gender, so one you have the female class and another you have the male class. Now, so out of these 30 people, 10 students are female and 20 students are male. Okay, and out of these 10 female students, we come to know that 2 play cricket. Okay, that is 20% of the females play cricket, and in the males we know that out of 20 people, okay, so 20 males we have in our total population. So out of these 20 males, 13 play cricket. So we have 65% males playing cricket. Okay, this is the scenario for gender. Now we will calculate Gini for these for this split. Okay, now let us concentrate first on the female subnode. Okay, so here we will apply this formula p square plus q square. Okay, so what is the probability of females playing cricket? So what is that? It is 0.2, right? 20%. Why? Because we have seen that out of 10 females, two females play cricket. So what is the probability? 2 upon 10, that is 0.2. So we will have 0.2 square. Okay, and what is the complementary or the other probability, which is that female not playing cricket? What is that probability? It will be 1 minus 0.2, right? It will be 1 minus 0.2, which is 0.8. So we will again get the we will take square of this probability. So 0.2 square plus 0.8 square, and when you add this, you will get 0.68. So this is the Gini parameter for female node. Similarly, we will calculate it for male. Okay, so in males, we have seen that 13 out of 20 people, out of 20 males play cricket. So we have 65% probability, okay, of people or of males playing cricket. So it is, so we will take 65 square of 65, okay, 0.65. And then what is the probability of males not playing cricket? It is 1 minus 0.65, right? So 0.35 square. So when you add this, you will get 0.58. And now for this split on gender, you will calculate the weighted Gini coefficient, which is nothing but you will take the weighted average of these of these probabilities. So so how do we calculate weighted averages? So we know that out of 30 people, 10 are females, right? And 20 are males. So you will take this fraction over here. So 10 divided by 30 into the probability of females. Okay, so 10 are the number of females. So 10 divided by 30 into 0.68. Similarly, for the males, we have the ratio or the proportion as 20 divided by 30, right? 20, because there are 20 males present out of 30 total number of students. So we will take this ratio and we will multiply it by the Gini for the males. Okay. So when you calculate this, you will get the your answer as 0.59. Similarly, so this we have this we have done. We have calculated the Gini parameter for the splitting on gender. Similarly, we will do that for splitting on class, right? So here we are splitting people based on their class. That is whether they belong to class 9th or class 10th. And based on that, again, we will follow the same procedure. So for the class 9 subnode, we have 6 people out of 40 which play cricket. So what is the probability? 6 divided by 14, which is 0.3. So we will square that. And then what is the complementary? That is 1 minus 0.43. That is the probability of students not playing cricket. So it is 0.57. So we will take square of that also and we will add both of these squares. So we get 0.51. Similarly, we will do it for class 10th. Okay. And then we will again, so here again we are getting 0.51 and we will take the weighted average of the probabilities, and here we are getting 0.51. So now based on the Gini parameter, we have come to know that gender, okay, gender is giving us higher Gini parameter, right? 0.59 is greater than 0.51. So our our model will first split on gender. Okay, this is how it it goes about. That is, which split is producing more homogeneous subnodes. Okay, and that homogeneity we can calculate by using this Gini parameter. Okay, so the more homogeneous subnodes that we get, we select that particular feature as our root node, or uh, or or the parameter for splitting. We select that particular feature. Okay, so this is how it works. Now here, since gender gives us a higher Gini parameter, we will first split our data based on gender. Okay, so here also you can see that we are getting more homogeneous subnodes. Okay, so the more homogeneous subnodes we have, uh, the better is that split. Okay, and that we and that split or that feature we should be using for splitting our data. Okay, so any questions you have? Any questions you have on Gini or decision trees? Structure we have seen how the decision tree works, and we have seen the first concept of splitting, which is the Gini. Do you have any doubts?
The initial numbers, do we feed? Is it like how many students play cricket, how many don't
No,
play cricket,
no, that
or that is all calculated automatically?
that is also calculated automatically. We do not have to put anything as such. So your data actually has all of this, right? So your model will automatically calculate this. This is just for the sake of demonstration, like understanding how Gini works. So this is a kind of a demonstration, but later you will see, while preparing the model, we do not have to provide any such information. It will automatically calculate everything from
Okay.
the data. So any more questions? So no questions. So let us move on to the second concept of splitting, like based on what we can split our data, or how our model can split our data. So just a minute, I'll share back my screen. I hope my screen is visible. Now, this is a very nice blog that I had come across, and I thought that I should explain this concept of entropy based, explaining from this particular blog itself. Okay, so now the next concept of splitting, which we can use, is that of entropy or information gain. Okay, so let's say we have this data. Okay, this is our data, So we have to predict, or we have to classify whether that particular animal belongs to species of mammal or reptiles. Okay, so this is our task, and we have some features with us, that is whether that animal has teeth or not, whether he has hair or not, whether this is another parameter, breathes, and whether that sorry, not person, that animal has legs or not. Okay, so we have these three features, or the columns we have with us. Okay, and this is our output. So this is actually the output that we have. This is the actual output. Okay, and we will be using these four features to predict whether that animal is a mammal or reptile. Okay, so now let's move forward, and over here we will understand first what is meant by entropy. Okay, so entropy is nothing uh, uh, but the impurity. Okay, so impurity in data set is nothing but is known as entropy. So more the impure your data set is, that is over here. You can see that in this circle we have just one colored circles, right? But over here you can see that we have three kinds of three different colored circles. So this is more impure. So this means that this particular circle would have more entropy value. Okay, so the more impurity is present in your data set, the more is the entropy value that you will be getting. Okay, so this is the concept of entropy from a very high level. And now let us understand over here how it is calculated. Okay, so entropy is calculated by this formula, that is probability for that particular feature, okay, into the log of that probability. So this is the feature, and of course the negative, this is actually minus of the summation of the probability of that feature into log of that feature. So this is the mathematics. We actually do not have to remember any of these formulae. Okay, the model will do this everything by itself. But just to understand what how it does all of that, we it is always good to know it, right? So these are all the features. uh, okay, so let's okay, so let us concentrate over this more. Okay, so let's say that we want to first select this parameter, which is the tooth parameter, in order to classify or make the first split in our data set. Okay, so what is the underlying process that goes? Okay, so first, like we have seen, if we decide that we want to split our data first based on this parameter, so we have two output over here, right? True and false, correct? So we have two output over here. If you can see in this data set, we have true, either true or false. So what it will do, it will first just a minute guys. Okay, I'll be back. Hello, sorry for that. Um, right. So we were seeing what would be. So we are trying to actually calculate entropy based on this tooth feature. If we select tooth feature, then what will be the entropy? We are doing that, right? So you are seeing over here that if we select this parameter first, then we would be able to divide our data set into two parts. So first one is is that is that animal actually has teeth, so it is true. And if it doesn't have teeth, so that is false. Okay, so in this way we can actually divide our data set into two parts. And then you will see that uh, wait, let me just explain this with the help of this formula that we have. Okay, so here you are seeing that first when the parameter is true, okay, and we know that it is mammal. So how many such combination or how many such data points are present? So if you see over here that that for this feature to be true and mammal and the output to be mammal, we have how many? 1, 2, 3, 4, 5. We have 5 such cases, right? We have 5 cases. So what is the probability that that animal to be mammal, okay, when it has teeth? So this is the probability that we are trying to calculate, right? So here you can see that 5 out of the 8 animals who actually have teeth, for which the uh, tooth feature is true. So such animals are 5. Such mammals are 5. Okay, out of the total animals which have teeth. So this is the probability of the tooth feature to be true and it being mammal. Okay, so that is 5 by 8. So what was our formula for calculating the entropy? It was minus the probability into the log of probability. So log with the base 2. Okay, this is the formula. So 5 by 8 into log of 5 by 8. So this is the probability. And what is the other half? Like so 5 by 8, out of 8, 5 are mammals, but out of 8 the other 3 are reptiles. So what is the probability of that? It is 3 by 8, right? So here also you can calculate, there are 3 reptiles. So 3 out of this total 8. So this is the probability for that animal to be reptile and also having teeth. Okay, so this is the probability. So again, we will apply the formula 3 by 8 into log of 3 by 8. So this is for this part. Okay, for this part, when the tooth feature is true. Now, again, we will follow the same formula when this tooth feature is false. So here you can see when the tooth feature is false and that animal is mammal. So what is the probability? So here you can see that only 2 people, sorry, not people, only 2 animals do not have teeth. From our data set, only 2 animals do not have teeth, and out of these 2 animals, one is mammal and one is reptile. So what is the probability that that animal not having teeth and being a reptile? So it is 1 by 2, right? 1 by 2 both for mammal and for reptile. So again, we will use the formula minus 1 by 2 into log of 1 by 2 for the mammals, and for reptile also 1 by 2 into log of 1 by 2. Okay, and then we will take again the weighted average. Okay, so for the feature tooth being true, we have 8 animals out of total 10 animals, correct? So we have 8 by 10 over here. You see over here, we are multiplying this this entropy into 8 by 10. which is nothing but the ratio. So eight animals out of 10 animals have teeth. So that's why we are multiplying it by 8 by 10. And for the other for the animals which do not have teeth, for whom the tooth feature is false, we have such 2 animals, right? 2 out of 10. So we are multiplying that, and finally we are getting this value. Okay, this is nothing but the entropy value. Okay, entropy value for this particular feature. So when we split our data based on this feature, this is the entropy value. Okay, and and then we will use this particular entropy value in order to get the information gain. So information gain is nothing but the information that the model derives. Okay, so the model gets some information based on the splitting of data on that particular feature. So how much is that information gain is actually based on what this feature is selected for the splitting. So the more the information gain, okay, the higher is the information gain, that particular feature is selected. Okay, so let us see how information gain is calculated. So we actually we actually subtract this particular information gain for each feature from the from the total entropy of our data set. So what is the total entropy of our data set? It has been calculated over here. See, so entropy is nothing but the impurity, right, in your data set. So that we calculate by using this formula. So for the whole data set, if we were to calculate the entropy, okay, not based on a particular feature, but for the whole data set. So we know that in our data set we have 6 mammals present. So you can go over here and see. This is our data set. This is our data set, and out of 9 or out of so out of 10 uh, 10 data points, we have how many mammals? 1, 2, 3, 4, 5, and 6. We have 6 mammals and 4 reptiles, correct? So come back to this formula over here. So see over here. So what is the probability of that animal being a mammal? It is 6 by 10, right? So 6 mammals we have out of total animals, which is 10. So 6 by 10 is the probability for that animal to be a mammal, right? So we are using that probability into the log of that probability. And then same thing for the reptile. We have four reptiles in our data set out of total 10 data points, right? So 4 by 10, that is 0.4 is the probability for that animal being a reptile. So 0.4. Okay, and again we will apply this formula, that is 0.4 into log of 0.4, correct? And then we will add this up to get the total entropy for our complete data set, correct? So 0.971 is the total entropy for our data set. And then come over here. Correct. So over here. So what is the formula for the information gain? It is nothing but the subtraction of our total entropy minus the entropy for that particular feature. Okay, right? So we had seen that we had got the entropy for, wait a minute, we were seeing for the tooth, right? Where did it go? Right over here, sorry. So what we had got 0.96 as the entropy for the split when we split our data based on this feature, this tooth feature. Okay, so we will find now information gain. Information gain is nothing but the difference between the total entropy of the data set minus the entropy for that particular feature. So we had seen this, that we had got 0.971 as the total entropy for our data set, and we will subtract the entropy of this particular feature, tooth feature. Okay, and then we get this as the information gain. Correct. Now, similar to this way, our model will estimate the information gain for all the features. So have a look over here. We have this breaths feature also and legs feature also, and our model is predicting. It is estimating the information gain for all of these features. And now for whichever feature this information gain is the highest, it will be selected for splitting. Correct. Now just compare these values and you will see that the information gain for the legs feature, okay, for this particular feature is the highest, 0.55 we are getting. Okay, so this particular feature will be selected for splitting. Okay, for the root node. Correct. So this particular feature will be selected to split our data, as the root node. It will be selected. Correct. So legs. So have a look over here. We are splitting our data based on legs. Correct. So if it has legs, then this is the split, and if it is false, then this is the split. And now you will be able to see that when the legs is false, okay, when that animal do not have legs, then we are getting very uniform distribution over here. Have a look over here. All of the animals which we have split over here are reptiles. So we are easily now able to say that, okay, when we split our data based on legs, so we can easily we are getting more uniform distribution, and when we do not have when the animal do not have legs, then we can classify it as reptile. Okay. Now again, when suppose this legs feature being true, so we have this kind of data set now, this kind of split in the data, right? Now again, we would have to split this data, right? Because in the end, we want only mammals and reptiles as our leaf nodes, right? We do not want mammals and reptiles both to be in our data set. We just want uniform data set. Now again, our model will go about calculating the information gain for the remaining features. Okay, so out of the 3 features that we had, we have used the legs feature for the first split. Now then we are remaining with tooth and breaths. These 2 features are remaining with us. Now again, our model will go about and calculate the information gain for these two features. Okay, and again, for whichever feature we have the highest information gain, we will select that feature in order to split our data. Okay, so here you see that we have got 0.3 as the information gain for tooth feature and 0 as the information gain for breath feature. So yeah, you would have guessed it right, that the next split will be done based on the tooth feature. Correct. So here you see again this data we are splitting based on the tooth feature, right? So we are dividing our data set, that is this data set, again based on the tooth feature. Again we have got now 2 splits. Okay, Now here you see that we are getting very uniform set. Okay, so now when an animal, if it has legs, okay, and if it has teeth also, then we would classify that animal as mammal. Okay, see, this is how the classification will take place. So any new data point that is coming to our model, it will first check that, okay, if that model is having legs, and if it is having legs, then it will check if it that model is having if that data point or if that animal is having teeth or not. If it is having teeth also, then it will classify as mammal. And then the remaining feature we are using in order to classify this particular data set. Okay, so the breeds feature is then used to further divide our data. And finally, we are getting these leaf nodes, which are nothing but our our classes that we have, or the classes based on what we want to divide our or classify our data points, right? So now let us take a quick break, 10 minutes break, and we'll come back by uh, what is the time now, 7:37. So we will come back by around 7:45. Okay, and then we will proceed with the decision trees. Okay, in the meantime, if you have any doubts, you can ask them now, or once you come back also you can ask, right? So see you after this short break. I see Anisha, Vishnu, and Vigneshwari have confirmed that they are back. What about others? Okay, Daniel has come back. Aishwarya has come back. Aishwarya, Jiju. Okay, so let us begin. I will share my screen again. Just a moment. I hope my screen is visible. So I have also shared these two links over here. So you can just check these two links and read about the entropy and Guinea. More about them from these two blogs. It is very nicely explained. You can have a read and understand both these concepts better. Okay, now let us see um, how we actually build our decision tree classifier. Okay, so we are importing our libraries which will be required. Then we are importing our data set. So we have this conversion data set. We had a look at this data set previously also. So this is how it looks, and we are trying to predict if our prospect, if we were able to convert that prospect in as our customer or not. Okay, so let us quickly run all this. We have seen all of this, and we will import this train test split. We have seen this also previously, right? We use this function to split our data into training data set and testing data set, right? Then we will import the decision tree classifier. So again, we will be using this sklearn library in order to import our decision tree classifier. Okay. So most of the steps of creating our model will be same, right? It is just the difference of the name of the classifier. So here previously we had the linear regression, then we had the logistic regression, Okay, only this name changed, but the steps remain the same. Now here again we had seen that since our source and country, okay, these two columns are actually categorical in nature, right? We have this UK, US, China, all these countries, and this sources of advertisement. Um, so these are the categorical data. These are not numeric in nature, right? So in order to use this data or use this data columns in our modeling, to create our model, we should first convert these categorical data into numeric data. Okay, otherwise our model will not be able to use this. It will just reject these columns. It will not run, because anything when we use as a text, our model will not understand that. Okay, machine learning is all about numbers. So even when we have categorical data, we should first convert it into numeric. So we had seen this dummification process, right, where um, we convert our categorical data into numeric. So here you can see that new columns have been created for each of the class which are present in that two columns, right? So we had this country and source data column, and we are using now this dummification. We're carrying out dummification on these, and you will see that we now get four columns or five columns. Okay, five columns for that particular country column, correct? And now since this first record had the country as UK, one is written under this particular column for UK, but for other columns it is zero. Okay, so similarly for the others also, it is converting our categorical or the textual data into numeric data, right? And then next step is to divide our data into the, so we want to categorize, we want to divide our data, take all the features together as the input data and our output variable as y, right? We had seen this also for the last two models that we have seen. So we want to take together all the features and separate out the output variable, right? So here you see that I'm using all, I want to use all of my columns except the converted column. So here I'm using this not operator. Okay, so now df new dot columns will give me all the column names, right? But I do not want converted, right? I want all the columns, but except this converted column, right? So I'm using this not operator over here. So let us run this. Then we are using the train and test split in order to divide our data into training and testing data set, right? We had seen this previously, so I'm not spending much time over here. Okay, so you see that in the training data set, we have some 221,000 rows, and in the testing data set, we have some 94,000 rows. Okay, now let us see how do we build our decision tree. So again, just like the other models which we had seen, we are going to call this method, call this class, and then use the fit function. And inside the fit function, we will be passing our training data set. So fit function is used to train our model. That is to create our model based on the training data set, right? So inside this function, fit function, we will pass our training data set, that is X train and Y train. So let us run this. And now we will check the accuracy. So accuracy we check using the score function, right? We had seen this also previously. So here you see that on the training data set, we get 98.8% accuracy. And on the testing data set, we get something around 98.5% accuracy, right? We can also use the other matrices that we had seen. So we had seen this classification report, which gives us the recall and precision values. So here you can see that we get precision as 0.99 for the 0 class and 1 as recall for the 0 class. And for the 1 class, we get 0.83 as precision and 0.65 as recall. Correct? Then this is the ROC curve, which just in this session we had learned. So this is the curve that we are obtaining. Okay. Now let us move to a concept which is known as hyperparameter tuning, right? So hyperparameters are nothing but the parameters that you can use, that you can specify while creating your model. Okay, so look over here. So all of these are the parameters that you can specify in order to create your model. Okay, so in order to improve your model also, you can use all of these parameters. Let's say see, now here we had seen both Gini and the other one, that is the information gain or entropy. We had seen these two concepts of splitting, right? These are nothing but the criterion. So here you can specify which criterion you want your model to be built accordingly. Okay, so if you want Gini, so by default, the criterion that is used is Gini. But when you specify criterion, when you pass this parameter, let's say criterion, I need entropy. So you should specify that. Okay. So these are the parameters or the hyperparameters. We call them as hyperparameters. So the parameters of a model are known as hyperparameters. So we can specify all of these parameters in order to improve our accuracy or the performance of our model. Okay, so all of these are the parameters, correct? So let us now how can we estimate what uh, like what should be the correct value that we should put or we should give to that particular parameter in order to get the maximum accuracy? Okay, so this is done by using hyperparameter tuning. Okay, hyperparameter tuning is nothing but determining what should be the correct or suitable value for your parameter that you should use in order to get the maximum uh, accuracy. Correct. So all of these are the features uh, of the decision tree that you can specify. So out of all of these features, let us consider one feature over here, which is maximum depth. Okay. So maximum depth feature is nothing but the levels that you want in your decision tree. So this let's say for this particular decision tree. So how many levels do we have? We have 2 levels, right? So similarly, you can specify how many levels do you want. Had I had specified only one level, then my decision tree would have stopped at this level only. So it would not go into another level, right? So this is how you can specify the uh, this is the max depth feature. So another thing for which these features you can use is for solving or controlling the problem of overfitting and underfitting. these are two concepts that we should understand while we are while we are working on all of these machine learning models. So what is overfitting? So overfitting is nothing but the situation in which your model is able to give you very good results on your training data set, but is not able to uh, give you good performance on your testing data set, or on the data set which it has not seen previously. Okay, so whenever a new data set is coming, and if your model is not able to perform more accurately on this new data set, then we will call this as the problem of overfitting. So we can take one analogy over here. So let's say in a class there are two students. Okay, so one student is he or she is learning all of the notes that he has, word to word. Okay, so he has some question and answers. Okay, he has some questions and some answers also to that questions which are given by his professor or his teacher. Okay, so he is learning those answers word by word. Okay, word by word he is learning. Whereas the other student that we have, student B, he is learning the actual concept which is taught or which is addressed in those questions. Okay, so he is learning the concept. He is not learning it word to word, but the concept. Okay, now let's say on when now both of these are appearing for a test. Okay, both of these are giving one exam, and in the question paper, let's say the same questions come. Okay, the same questions which the teacher has given them, the same questions come. Okay, so who do you think will be able to perform very better? Who will get the maximum marks? The first person, right, who has learned each and every word to word answer, who has actually mugged up all of the answer, right? So that person will get highest marks. Okay, but now let's say the question paper that is given has some questions which are different than the questions which are provided by the teacher in the class. Okay, so now what do you think, who will perform better? Whether the first person will perform better or the second person will perform better, who has understood the concept behind whatever is taught in the class. So who do you think will be able to perform better? Who will get the maximum marks? The second person, right? The second person who has understood the concept will be able to answer those new questions correctly. Okay, so similar to this analogy is this overfitting concept. So when your model is trained so much on your training data set that he is able to give you highest accuracy on your training data set, but when a new data set comes, okay, so when a new data set comes, your model is not able to perform well. So this is the situation of the first student, right? So your model is not able to perform well on the new data set. So this is the problem of overfitting, right? But we want our model to be like that of that student too. Okay, the second student, we want our model to actually be able to perform better on our testing data set, right? On the data set which is new. Correct. So we want our model to be like that of student 2. Correct. So in order to control uh, this overfitting problem, we also use this max depth feature, or some other features also we could use, but we could specify this feature also, right? So maximum depth, let's say if I do not provide, then my decision tree would go on growing and growing and growing. So there will be no limit until it has reached, very last stage. Okay, so this may go on for very for very granularity. Okay, this decision tree could go to very granular level, so that it will be able to, predict very clearly or very precisely the training data set. Okay, so the values that you have in your training data set, if you use them, those in your model, then your model will predict it very accurately. It will give you the result very accurately. Okay, but in this scenario, if a new data set will come, then your model will not be able to perform or give you good results on the new data set, which is not what we want. We want our models we want our model to work better on our training, on our testing data set, right? On the data which it has not seen previously. Correct. So this hyperparameter tuning can be used to control this problem of overfitting also. Okay, so what I'm doing over here, I'm actually creating one for loop over here. So let's say I'm first giving or creating a sample for my max depth. So let's say I'm saying that I want to create values between 1 and 32. We have seen this line space function in NumPy, right? So I'm using that function in order to create my list that I want. So I want to select what is the appropriate maximum depth value out of 1 to 32. So I have all of this sample 1 2 3 4 up till 32, and I want to know which is the most accurate or most suitable value for maximum depth out of these values. Okay, that is so how will we decide that for whichever model or whichever maximum depth value we get the maximum accuracy, we will select that value as our maximum depth. Okay, so here you see I'm doing nothing different. I'm just creating my decision tree. Okay, based on that particular maximum depth from my this list which I am getting, or array. Okay, so I have created array of numbers from 1 to 32, and I am using each number from that array in my decision tree classifier as the value of maximum depth. Okay, I will create this decision tree, then I will fit my or make my model learn from the training data set. Then I'm getting, and then I will get the predictions. Okay, I will use this predictions. Then I will find out this false positive rate, true positive rate using this ROC curve, which today only we have seen, right? Today only we have learned about this. So I will do that, and then I will then calculate my ROC AUC value. Okay, this is the score that I will be getting for that model which I have created. And then I will append both of these scores, uh, the test result score and my training result in these two empty list which I have created. So when I run this, I will finally get these two lists which will have the scores, that is ROC AOC score for every model which I have created based on these features, for based on these values of maximum depth. Okay, and then I will plot. Okay, so let us run this and see the plot. So it is running. So now now when I get this training and testing result, I will use both of these result to plot my graph. Okay, so here you see I have plotted my the number of the value of the tree depth that I have taken and the corresponding AOCE score. I have plotted this in this graph. Okay, for both training and testing. Correct. So now here you see that till one point of time we had both the training the AOC score for training and testing data set as same. Okay, but after when we increase my tree depth, correct, when I do that, you will see that my model is able to give me more score or higher accuracy on my training data set. So blue one is actually my training data set and the red one is my testing data set. So the accuracy for my training data set has increased, but the accuracy on my testing data set has decreased. Correct. So this is the problem of overfitting, where my model is able to give me a higher score or higher accuracy score on my training data set, but lower accuracy on my testing data set. Okay, so we do not want this. So based on this graph, correct, you can now estimate that uh, what should be my optimum value of the tree depth. Okay, so here you can see that we can choose somewhere around 7 or 8. Okay, we can choose around 7 or 8. So here you can see, so this is the optimum point. Correct. So here for this we have value of tree depth as 7 or close about 7 or 8. So we can choose 7 or 8 as the optimum value for our parameter. Okay, which is our parameter? Maximum depth, max depth parameter, right? So now here you will see that I am creating my model again, but this time I'm specifying my parameter over here, maximum depth parameter over here. I'm specifying that as 7, correct? So I will run this and you will see that I have got some improvement in my score, correct? Compared to the last one. So in this way, by adjusting the hyperparameters, you can improve the accuracy or the score of your model, correct? And you will see that recall has also increased. Okay, so previously we had 63%, now we have 71%, correct? So that's all for decision trees. So now you can ask any questions that you have.